Okay, so water, like most liquids, are gonna have a pH. A pH is just measuring how many free hydrogens are in that. So in pure water, you're gonna end up with kind of this trade-off between how many hydrogens are attached to the oxygens and how many are just free floating around. And that's what we call our neutral level of pH. As you start getting more hydrogens, it starts getting more acidic. As you start decreasing hydrogens, it gets more basic, away from this pH of 7. So pH is the negative log of your hydrogen ions. So if you have 1 mole of hydrogen ions per liter, you have a pH value of 0. If you have 0.1 mole of hydrogen ions per liter, you have a pH of 1. And this is on like the line of hydrochloric acid or stomach acid. If you have one of 0.0001, that's like a carbonated beverage, right? So a soda. And then as you go down, acid rain is like 3 or 4 zeros, and then you come down to things that are more alkaline, like a lot of your cleaners are really basic, like ammonia or oven cleaner is going to be really basic. They don't have a lot of free hydrogens. In fact, they have a lot of free hydroxides or OHs that are also dangerous, right? So acids and bases, is the further you get away from that 0, the more dangerous they become. Water, again, we talked about it. It's really good at eroding stuff. So those hydrogen ions are really reactive. So if it starts getting kind of acidic, they start to pull minerals from rocks and soils. Specifically limestone, it really likes to pull the calcium out of limestone. And that way you can get these really cool limestone caves where water is pulling out the limestone as it drips through the earth, or these limestone pockets, and then leaves little bits of it, and so you can get really neat stalactites. As it pulls out that calcium, those free hydrogens meet up with it, and you start making stuff like calcium carbonate, right? So here's calcium carbonate, and then you get your calciums and your carbonic acid. We have some naturally, like, really acidic bodies of water, like bogs, especially like peat bogs and stuff that you find in the UK. Like swamps have really high acid contents from the breaking down of those plants in those bogs and swamps. It causes the water to become pretty acidic. But we've also made our own acidic bodies of water with coal-powered industrial plants. They produce sulfur dioxide and nitrogen dioxide, and so they can form stuff like nitric acid or sulfuric acid. And there for a while, like, this was a big deal. This created something known as acid rain. What we call now is acid deposition. So they're releasing this sulfuric acid, right, when it's in the air, and mixing with the water vapor or this nitric acid. And then when it comes down, it's going to come down as really acidic water. And it destroyed a lot of stuff like statues and life. Those higher acid contents really did a number on spruce and fir trees. So in the more northern parts of the country, you would see like these swaths south of these plants where all the spruce and firs started dying because they're bringing in all that acid. But from like 1980 to 2015, the emissions of the sulfur dioxide declined by 84%. So they put in scrubbers on these coal plants to help pull that stuff out. We actually have a coal power plant just north of us, up 144, It's at the Sooner Lake Dam. And they are putting in some new scrubbers now to also pull out carbon dioxide to limit the increase in greenhouse gases. Another thing coal plants can do is thermopollution. So they're using steam to power the turbines or whatever. And then that steam condensates, and then they just release it back into the lake or whatever they're hooked up with. And that can increase the water temperature, dangerously so, if it gets over like 45 degrees Celsius. The EPA has a thing where it's like, you cannot release any water over 35 degrees Celsius. And we'll talk about like why getting too hot is bad in a little bit. But so they would release a lot of, or they could release a lot of hot water that could then kill the animals. The Sooner Lake Dam power plant is really cool, and they do a great job of staying within the EPA regulations. And if you go out there, you can go fishing on Sooner Lake, and a lot of people like to do that because that plant keeps the water warmer longer, especially in the winter. And so the fish are able to grow bigger in shorter periods of time. And so there's some pretty good sized fish out there if you like fishing. All right, so brain check. What is unique about water and how temperature affects the density? How can viscosity both hinder and facilitate movement in water? So as water gets hotter, it gets less dense. As it gets cooler, it gets more dense down to 4 degrees Celsius. And then anything below that, it gets less dense. And then it's ice, which floats. How can viscosity hinder and facilitate movement? It hinders movement because when you push against it, it pushes back. It facilitates movement because it gives you something to push against. All right, and we will pick up with the challenge of water and salt balance.